Hi, my name's Mark, and today I'm going to show you a quick run-through of what I've been working on so far with my big Capstone project. First, a quick reminder of what my project is. I'm making a game in Unity. It is essentially you rotate this cube around, and on 3 of the faces there are little puzzles that you have to solve. So, and on those puzzles there's little pieces that you can move around to try and solve the puzzle. As you play as well, there are objects that randomly spawn for you to pick up for extra points. So what I have so far and what I'm going to show you is the initial cube rotation, so moving the whole thing around, and how the spawner actually works. So this is what I actually have so far. So it starts up, and use this to move the cube around whichever way, and there are objects spawning in the world. Later on there will be objects spawning on more than one side of the cube, and not like every second. It'll be more like every 30 seconds, random amount between 0 and 4 objects will spawn at one time is the goal. Well, let's get started. First I'll open up my Unity, and first off, this shows in the game the cube and the touchpad. This is just a placeholder. That's not actually what I'm going to be using for the touchpad to move the cube around. In the level, we have the touchpad here, our camera, the cube itself, which has the cube, and its spawner. If you look in this area here, that is the spawner. That's where the objects will be spawning from and then falling towards the center of the cube. I have my project set up. Any reference images just for testing. The sphere for the object that gets spawned, my scene, and a list of some of the scripts I'm using. So first, I will explain how I get the rotation of the cube working. Load this up here. So this script is already done and it works. I'll just run you through all the stuff involved in making it work. So up here, have all of my variables that control the script and do what it needs to do in the scene. Or I have a float that controls the rotation speed of the cube. It's default set to 100, which is kind of fast. We play around with that. I have it set to public so I can change it whenever I want in the inspector. I have a public int for invert pitch, which you can set it to either 1 or -1, and it will change the direction of the rotation depending on which way you slide your finger. So if you slide your finger to the left, the usual rotation of the cube will go with the direction your finger is sliding. But you can set it the opposite, so that when you slide left, the cube will actually rotate right if you choose to. So that's in there. Have floats set up for the pitch and yaw, which are set for the vertical and horizontal rotation of the cube. An int for current touch, which you can reference back to for other scripts saying this is where my finger is touching on the screen. I have array, which will be explained in a minute of what that is. Again, raycast hit I'll be explained in a couple of minutes. I have a public transform here called cube, and that's the object or the transformation object that gets manipulated by this script, so the cube. And in my update loop, I have it calling to find out if there's a touch on the screen. That's what this is right here. And it's just the way the touches work is like 0, 1, 2, 3, and so on. So you can actually receive more than one touch on the screen, more than one finger if you wish. This is just looking for the 1. So 0 is where it starts. This here will loop through if there are any other touches on the screen. So if you have 2 or 3 fingers on the screen. This makes it so even if there are more than one touch on the screen, it will still work as if there's only the 1 on the screen. Debug system here just telling me that 0 touch is there. It just tells me in the engine for testing it's being touched. And down here, this is telling me that when you're touching the screen and you move, that it's actually getting that movement. So it can tell that you're actually moving from where you touch to another position on your screen. It sends a message out so it can debug that. And now this is where the ray and hit come into play. The ray it's a ray cast. So when you touch the screen, it basically sends an invisible ray into your game. And it needs to hit something for it to actually do something. If you touch and it's just going, it's not running into anything, nothing is going to happen. It'll just be as if nothing's being touched at all. This just senses the phase of your touch, and this references back to the touch moved. So when you touch, it sends out the ray to what should be touched for it to do something, and then your movement. And then this physics.raycast, ray, out hit, is the camera actually getting a response from your hit. So you touch the screen, send the ray into your game, and it hits something and it bounces back. That bounce back is telling the script to do what it's supposed to do because it knows it's being touched. If you don't get a hit back, it won't do anything. And the actual thing we want it to do is this on-touch movement down here. The pitch and yaw, so the vertical and horizontal movement. So this receives your touch, so your touch 0, the 1 finger. This delta position, the basics of it is it knows your initial touch, your first touch on the screen, and then it actually records your movement on the screen if you move your finger somewhere else. That's what that does. That records that on the X and Y, which is your vertical and horizontal. Multiplied by your rotate speed, so it can actually tell it to move this direction in that speed. And your invert pitch, just to tell it that it's moving the opposite of your movement or with your movement. And then time.delta time is just the in-game time, so it moves properly. Now, in the scene, how this script actually works. I made this GUI texture. Just make a new GUI texture. That is the default GUI texture that pops up. You can swap it out for any other kind of texture you might have in your assets. I have this little picture that is from another game. It's just for reference, so I don't need that. So this is the one I'm using. Don't know why that happened. Okay. I attach the swipe rotation script that I just explained to you. I set the speed to 10 and the invert pitch to -1, which should be the appropriate direction with which you're swiping. And I attached my cube, which is this game object right here, into this slot. So what that does is where this texture is, a GUI texture is in the game, that area, essentially this area here, is the only place that will get the touch to rotate the cube. It won't, if I touch over here, nothing will happen in terms with rotating the cube. Only here, when I touch this area here, it will be influenced. Now I will show you how my spawner works. So I'll open up the script. And, okay. So this is my pickup spawn. This is for the object that drops randomly in the game for the player to click and pick up. So I'll run you through this. So I have a spawn position for the position of the object where it actually spawns. Let me try that again. This vector3 spawn position tells the object to spawn in a certain spot on that side of the cube. The game object is, this public game object is for the object that gets picked up. 2 floats for next spawn and spawn rate. The next spawn tells the spawner to spawn the object in intervals of around 2 seconds. And the spawn rate is how many get spawned every time it's called to spawn. And this public transform is for the cube game object. So everything that's involved in the actual cube gets thrown into that. I'll explain why that's there in a bit. In the update loop, we have time.time is greater than next spawn. So it's calculating the time gone through as the game goes on, so that it can calculate when the next spawn will actually happen. And then when that does happen, the onEnable script, which is down here, actually happens. So what's happening in here is the spawn position is a new vector3, so x, y, z, for the actual position of the object. And each x, y, and z have a minimum and maximum position with a random.range attached to them. So it's just, this randomizes the object in this axis. And the bounds portion of this, I will show you in the scene, is a game object, just a cube, set to isTrigger so nothing will collide with it, and about the size of that face of the cube. And what happens is the object will randomly spawn within the bounds of that spawner cube that we made. And down here, I had to throw this in here for the instantiation, so the actual spawn, because what happens with just this, it spawns, but it just clones the object into the scene, wherever, just so that it's there. It doesn't spawn it anywhere specific. So what this does is it actually tells the game object, the clone of that object, to actually parent or be a child of the world, so the cube. So it actually spawns inside of that game object. I'll explain why that needs to be there. So first, I need to make a prefab of a sphere. So I created a sphere inside the scene, just like that. I resized it so it was small, moved it over here, and shrunk it down so it was kind of a good size. And then I just dragged it over into here, and that is what makes this a prefab. And I don't need it in the scene. So what happens is I made this cube. Okay, that's the spawner. And it's about the size, just a little bit smaller than the actual face of the cube itself, just so that it won't fall off if something spawns right at the edge of the collider. And the settings over here, I have my pickup spawn script, which is what I just explained. So the next spawn and spawn rate, I have it public so if I ever wanted to mess around with it. And this is where the game object for the pickup goes. So I just dragged and dropped that in there. See how it highlights? That says that you can actually drop that in there. Same with this game object, it's transform for the world. I dragged this game object into there so that it will actually, when it spawns, it will spawn inside of this little drop down menu here instead of somewhere else in here. Actually, I can play this and you can actually see where it will spawn. The spheres are spawning inside of this game object. If I actually got rid of that, this little bit, and delete that, save that. So the whole instantiating into that parent group, so the game object, is gone. And play again. And now you can see the sphere is actually spawning outside of this little group. Why I have it spawning inside of the group instead of out here is because when in gameplay, when I actually rotate the cube, because of the direction the objects are falling, if I rotate the cube, they'll just fall off into space and just keep going in that direction, which isn't useful at all. So I need to have it parented underneath this game object so that when I rotate the cube, those new spawned objects will actually go with it. And now I'll show you the artificial gravity, because the initial gravity, if you look inside of here, Unity's default gravity is actually in the y-axis, so that's the up and down axis in Unity. And the gravity is set to that direction. So it's minus 9.8, I think the default is set in Unity, so it falls this direction. So right down is the actual proper gravity. So it simulates real-world gravity. So I had to make a artificial gravity script, which is just this little small thing. It's just this one line in the update loop that tells it to fall in a different axis instead of the Y. So the default is actually set to here, so that it's actually the up and down. I switched it to the x-axis because that's the direction of the face I'm demonstrating at this time. I can change that to any one of these directions. I can also take away the negative sign and it'll go up, or the opposite direction in X. So if I actually had only 9.8 here, it would actually, the gravity would actually make the object go up instead of down. I have this set to manipulate the objects, the spawning object's rigid body. So essentially its weight to add relative force. I played around with this originally and only had add force so that it would actually be being pushed by an invisible force in that direction. I found adding this relative part will only make it use its axis instead of the world axis. The add relative force, so if I got rid of this relative, so just add force, manipulates the world axis. So what happened was I just had that and threw it in, and I would rotate the cube and it would stay in its position and keep going. It would fall off of the cube and just keep going. So adding this relative force is it's using its own axis, so it stays in its proper position facing that direction that the force is pushing it. So it simulates that it's actually falling towards the center of the cube. I found that kind of really cool. And I also threw in a touch script just to destroy the game object whenever I wanted, which is just this little bit down here. It finds the game object that's tagged, and whenever I touch it, it finds that game object and destroys that certain game object. That's all that does. This is just so I could keep playing around with it and get rid of the game objects that keep spawning. And that's as far as I am right now on this project. There is a lot more to come. So the proper spawning, the objects that you can move in the game on each face, so there'll be a puzzle here, a puzzle here, a puzzle here, and when it's done, it'll be really cool. Thanks for listening, and I'll talk to you soon.